Okay, so in getting ready to prepare our drainage plan, like I said, we are going to define a watershed area. The watershed area is going to be around the whole site. Let me see if I can get this back here. So it's going to be around the whole site. So that's going to be our watershed area. So we're going to trace it with a polyline all the way around the site. And as far as the polyline, the layer that I wanted to create is this one called C for civil, dash DA for drainage, dash PROP for proposed. So this is going to be our proposed drainage area. So we need to draw that polyline so that we can define the area to put it into our rational formula of Q equals CIA. As far as that layer, the CDA PROP, that one right there, we're going to use color number 244. So make sure you make a note of that we're going to create a layer, CDA prop, color number 244. We're going to make it a hidden line type. And then that's the one that we're going to draw with a polyline. The polyline will then define the polyline and get an area out of it, convert it to acres, because the Q equals CIA is in acres for the A on the rational formula, okay? As far as the polyline needs to be a width of 1.5 feet. Okay, so the polyline we're going to draw has a width of 1.5 feet to then be able to draw it and be able to visually see it on the plan, so that once we have our final plan, we'll be able to see it with this polyline. And the next thing that's going to be coming up that we're going to be doing probably next week is how to create a PDF with line weights, because the pavement is supposed to be shaded, the drainage area is supposed to be shaded, and we need to have different line weights and line types. So I'll show you how to do that next in a separate video, of course, how to create our pen settings so that we can create PDFs with all the appropriate shading to make it look like a nice final grading and drainage plan. So once again, the polyline we need is a 1.5 width for this one in particular. So once we have that layer, I'm going to go ahead and set that layer as my current layer. I'm going to draw in a polyline. And the polyline, I'm just simply going to trace the property line from this corner. I'm going to add a width of it of 1.5 starting and ending with, and then start drawing in my polyline. And I'm just going to simply trace all the way around to where it's supposed to drain. Now, would I go necessarily to the property line? Not necessarily, because water is going to stop at the rock wall. So there's a rock wall here. So I'm going to just stop at this corner here and then go all the way to this corner here and just kind of trace where water is going to be, okay? So I'm not going to trace the whole thing. I'm going to have you do that on your own. But what's going to happen is that once we have that shape, let me just show you how to get the A. Is I'm just going to create a random shape. It's not going to be exact all the way around, okay? Once we have that shape, we need to get the area out of that shape. Of course, we do need to be closed. So I'm going to go ahead and close this up here. So it does need to be a closed shape. Once we have that shape, what we're going to do is we're going to use our properties command, PR for properties, select the shape, okay? And down in here, we're going to get the area. There's the area, okay? So the area in this one shape, please don't use this number because it's not correct. Yours is going to be different. That number that I have here is 19899.30. Okay. So that area, if you remember area is length times width. Area, it's something squared. And remember, as far as civil engineering, we're working with decimal feet. So the area happens to be square feet. Square feet, okay? Now, does that mean that that's what the number I'm going to plug in on my calculation? That is not. That is not. So I'm going to go ahead and write that down. 19,899.30 square feet. Okay. But the number we're going to put in here is actually going to be pretty small. Okay. Because remember, the area does need to be in acres. So how do we get acres? How do we get acres? We need to convert. So what we're going to do is we're going to take the area. The area, I'm going to take it divided by 43,560. Okay, 43,560. Now, what is 43,560? That is the amount of square feet in 1 acre. 43,560. How do I know that? Because I've been doing this for many, many years. I just happen to know 43,560 is how many square feet there are in 1 acre. So I'm going to take the area divided by 43,560 equals 0.456825. So we're just going to use the 2 decimal places. So my area that I would use for my Q equals CIA rational formula, the A would be 0.46. That's what I would use. You will use a different number because you need to trace the drainage area with your polyline and you calculate your area. But I just want to show you, once you get that shape, you're going to take that area divided by 43,560 to get the amount of acres there are in the formula. So once you get those acres, that's what's going to get plugged in on the chart on the A right in here. Okay. The C, you're going to get the C based on your storm frequency. The TC, we talked about that. The I, you're going to calculate to eventually get Q equals CIA. So the Q is going to be the C times the I times the A. That'll give you your Q in CFS. CFS is cubic feet per second. You might have to refer back to the PowerPoint for that. Okay. So we need to get that number, and that's what's going to be your drainage calculation. Once we have the polyline, once you have this chart drawn in with the numbers, you're done with your drainage plan. That'll be due, indicated on the classroom, Google Classroom. So check your Google Classroom to see when the drainage plan is due.